Hello, Mr. Betts here. Let's take a look at another example where we have a definite integral that we want to evaluate with antiderivatives. In this case, what I'm going to do, since we have a quotient and we don't know how to undo the quotient rule, I'm going to look at this as a division problem first. So essentially what I'm going to do is I'm going to rewrite that integrand as an equivalent expression, and then we're going to evaluate it from there. So if we're doing this and we only have one term in the denominator, we can divide the numerator term by x squared. So this is going to be the same thing as the integral from -1 to 3. I am going to group this because we are going to have more than one term. So I'm going to use parentheses. So x cubed divided by x squared is just going to be x. -5x squared divided by x squared is going to be -5. 2x divided by x squared is going to be 2 over x. And for purposes later, I'm going to think of this as 2 times 1 over x. So keep that in mind. And then minus, actually I'm going to write it that way right now. And then we're going to have minus 3 over x squared. And for using the power rule, I'm going to write that as 3x to the -2. So antiderivative this time, at this time. So antiderivative of x, so what do we take the derivative of to get x? Well, that's x to the first power. So using the power rule, we're going to have x squared over 2. Antiderivative of -5 is going to be -5x. Antiderivative of 2 times 1 over x is going to be 2 times the natural log of the absolute value of x. And at this point, I want to point out that we can't do this. And the problem we have here is that 1 over x crossing over 0, which is between -1 and 3, we have a discontinuity, and it's an infinite discontinuity. So not yet. Now, I don't want to stop here because I want to make sure that we understand the process that we're using here. So to deal with that, I'm going to change the problem a little bit and make this a positive one. So by making that a positive one, we're not crossing over that discontinuity. We would end up with that discontinuity here with the 3 over x squared also by crossing over 0. So let's continue with the new limits. So a new problem. Antiderivative for the 3x to the -2. So we're going to increase the power by 1. We're using the power rule here. So it's going to be x to the -1. And then we divide by the new power. So we're dividing by -1. So we're going to have a positive 3. And I'm going to write that as 3 over x. So that's our antiderivative of the integrand. And then we're going to evaluate that from 1 to 3. Notice the square bracket notation allows us to group and use the evaluation bar all at the same time. So now I need to evaluate it at those points. So we have 3 squared over 2 minus 5 times 3 plus 2 natural log of 3. By the way, I do want to point out we do need the absolute values here, even though these are both positive, because the antiderivative of 1 over x is natural log of the absolute value of x. Now that I've plugged in the 3, I can get rid of the absolute value. And then plus 3 over 3, and then minus, the grouping here is really important. We need the parentheses, especially with this one, because we're subtracting it. So we have 1 squared over 2 minus 5 times 1 plus 2 natural log of 1 plus 3 over 1. And for a free response problem, it's actually okay to just box this and be done. If we are simplifying, just a couple of notes, the natural log of 1 is equal to 0 because e to the 0 is 1. So that can drop out. We can't simplify the natural log of 3 at all, so that's just going to be in our answer. Other than that, it's just arithmetic to simplify.